The universe has an end, as researchers proved. There is nothing that resembles the sun that we can see as far as the cosmos. The celestial horizon, the extent to which we can observe it, is the sole limit we are aware of for our universe. For instance, scientists think that the universe may not be as old as previously thought. We are unable to observe the entire universe as light because of the Big Bang, which occurred 13.8 billion years ago. Has only had 13.8 billion years to complete its journey, constituting the entire observable universe. But what is beyond this discernible bubble, where uncountable galaxies extend as far as they can? Or is there a real end to the universe? Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon to find out if the cosmos is infinite today. Approximately a century ago, two brilliant scientists named Herbert Curtis and Harlow Shapley met in the Great Natural History Museum Auditorium, Smithsonian Institution, Washington, D.C. to argue over the seemingly insignificant topic of the size of the universe occurred just before Edwin Hubble uncovered the characteristics of galaxies. Curtis claimed that the universe might be made up of numerous distinct island universes, asserted that the spiral nebulae were far-off star systems outside of the Milky Way. Shapley thought that the so-called spiral nebulae in the Milky Way were just gas clouds. As part of his idea, Shapley also placed our sun in a corner of the Milky Way. Odd universe. The sun, according to Curtis' counter, is rather close to the galaxy's nucleus. These two individuals were incorrect and right at the same time. Curtis largely understood the immensity of the cosmos. Shapley was undoubtedly correct, but he miscalculated the sun's position in our galaxy. Despite being inaccurate about the vastness of the cosmos, he was pretty precise about where the sun should be. Since then, a lot has changed. We now have a greater understanding of the observable universe, and in 1996 the dispute was brought up once more, and this time galaxy researcher Sidney Vandenberg was involved, and Gustav Tammann, who engaged in a debate on this issue. Gustav Tammann vehemently maintained that the Hubble constant only has a low value of approximately 55 kps/parsec, but Vandenberg offered evidence in favor of the Hubble constant being larger than 80 kilometers per second per parsec, indicating that the universe might be smaller and younger than scientists previously believed, according to the Hubble constant. For those who are unaware, the universe's expansion is measured in a way that is easy to understand. Since the universe's creation during the Big Bang, the cosmos has been expanding. Fact accelerates more quickly as it gets bigger, but Tammann did have some powerful arguments. Both of them had evidence to back their positions, but neither was able to persuade the other scientists from the opposite camp. Even now, 25 years after that argument, astronomers are constrained by both of these. The cosmic distance scale has not yet been agreed upon due to assumptions and a lack of sufficient data. Based on the accessible data, astronomers can place some restrictions on what must be accurate regarding the universe's size. Now that there are large telescopes available, scientists can see galaxies. Our current cosmic horizon of vision is somewhere at a distance of more than 13 billion light-years from Earth, approximately 26 billion light-years across. However, it is undeniably true that the cosmos should be far larger. If Alan Gough's 1980 hypothesis, which is substantially greater than what we can currently see, is correct. If this is the case, the cosmos must have ballooned in its initial moments due to its fast expansion. Nearly instantaneously went from the size of a subatomic particle to the size of a softball. If inflation really did happen, the cosmos is far bigger than we would think. Expectations based on recent observations are where things start to turn, for lack of a better description, weird. We showed how in our movie regarding whether the Big Bang was a white hole, link in the description below. Keeping in mind that the Big Bang didn't happen at a particular location but rather everywhere, inflation earliest moments of time and space, it should have happened in numerous instances. It is a reasonably valid school of thought in many places, and possibly many here implies in an infinite number of locations. Believed that many of the locations where inflation helped expand the universe may be beyond our current understanding. In that case, the cosmic horizon and the boundaries of the space-time continuum we are so familiar with, either our universe is infinite or another cosmos outside our range of perception exists. Andromeda, there are approximately 2.5 million light-years between the Milky Way and the closest galaxy. When we attempt to observe what is occurring there from a distance of years, we are actually viewing we don't know what the Andromeda galaxy looked like roughly 2.5 million years ago. Because the light from that galaxy cannot arrive any sooner than it does from our own light, must travel 2.5 million years from the moment of emission to reach our sight. We find ourselves peering backward in time to more distant galaxies as we travel farther. Appear to have existed millions, billions, or even tens of millions of years ago. The light from the universe is increasingly farther distant from us as we gaze into space. When we were younger and persistent in finding explanations for anything the light made visible to us, we've discovered the light that the cosmic microwave background first released way back when. The cosmic microwave background, or CMB, is the lingering light left over from the Big Bang. Discovered that the cosmos was flawless, with the exception of a few areas being more or less dense. These non-uniform regions made up just 1 in every 30,000ths of the entire cosmos. However, this much space was sufficient to produce stars in the enormous cosmos that exists. We can now observe galaxies, galactic clusters, cosmic gaps, and surprisingly, space a totally flat curve. If not for it, distant lights would either converge or diverge. However, despite our current changes, light always travels in the same direction, showing absolute flatness. Based on the information presented above, we can infer that if the universe if it is finite, it must be at least 250 times larger than what we currently refer to as the observable universe. We exist in a three-dimensional universe, hence the calculation justification for it is that 250 times the radius is 250 times the volume, or more than 15 million, to the third power. That would be around 11 trillion light years in all directions and times as much space. But even as large as that is, it is not endless. Now let's consider what is beyond that edge, if the cosmos indeed has one. There is reason to think that the universe may not have an advantage at all given what we know right now. Suppose the observable universe as we know it did indeed begin with the Big Bang, but what if time and space? We are aware that prior to the Great Bang, there was an abundance of matter, that space was expanding at a constant exponential rate and contained just the energy intrinsic to space itself. Refer to cosmic inflation. In addition, new space was formed so swiftly that it exceeded the lowest physical length scale. Every 10 to 20 years, the Planck length would be expanded to the extent of the currently observable universe. The 32 seconds in reverse. Despite the fact that inflation has ended in our part of space, we still require answers to 3 problems, the first of which is how big the cosmos was before inflation that gave rise to our second most popular major bank is the notion of endless inflation. Third, how long did inflation last before it ended and the hot huge bang that followed? These inquiries are so broad that a full explanation of the responses would be necessary. Based on its own film and our best observations, we can conclude that the cosmos is much larger than beyond what we can now see. We can only observe a small portion of the cosmos. Similar to ours, with the same physical laws and cosmic phenomena out there. Whether there are several worlds or just one, both have the same structures and opportunities for sophisticated life. Or, if you like, a multiverse, then anything we may discover at the end shouldn't be infinite. Unless inflation continued for truly infinitely long periods of time, unless the cosmos was created infinitely large, in which case its size should be limited. However, in order to obtain the right response, we might need to find a means to go beyond what can be seen. The universe itself could contain the answers somewhere else, but until then, the options are endless, so please share your ideas with us in the comments. You enjoy learning about the world before the Big Bang, and thanks for watching as always.